Hello, I'm Daisy, and we are continuing on our quest to learn Python. And, yeah, I'm trying to start early so I can get to bed early. Went to bed really late yesterday, like, very, very late. Like, I think like 9 in the morning, 9 or 10. But I slept like 5 or 6 hours, which is bad. We're trying to do better than that, but so I do wanna I'm gonna try to call it early. If I start feeling tired, I'm not gonna try to push myself too hard, because the more I miss out on sleep, the harder all of this is gonna be. So, well, without further ado, let's get right to it. Let's see, Python. This is what we're doing. 73 out of 102 steps. We're almost there. I'm going to build a discount calculator. Alright, we will define a function that calculates the final price of an item after applying a percentage discount. So it's 50, and there's a discount of 20, and the discount amount is 10. Wait, what? If the price of an item is 50 and a discount of 20 is applied, the discount amount is 10, and the final price is 40. So 20 as in like 20%. Because that would be 1/5. Yeah, I'm assuming it's talking about percentage. Fulfill the user stories to complete the lab. So, def. Apply. Oh boy. Yep, one of these days I gotta start doing some typing practice. I kind of want to do that on stream too. I'm not sure what streaming category that would be though. Because I don't feel like that's science and technology. I mean, it could be. A keyboard is technology. Anyway, let's see. Oh, whoops. You gotta do that. Okay. And then a colon. Yeah, and the moment I type one thing, all my errors go away. Okay. Discount function should take exactly 2 parameters. Price and discount. Alright, let's put those there. Price, discount. Alright, if price is not a number, an int or a float, the function should return the string, the price should be a number. Wait, so would I make an if statement then? If price, can I say is int or float? Okay, yeah. Oh wait, is not. Would I have to say not int or not float? Just to be safe, let's do parentheses. Again, we're not really aiming for readability. I just want to, that was the theme of yesterday's lab, or the other lab. Not readability, just making a code that works. If price is not int or float, yes, print. Oh, no, wait. Return. The price should be a number. Price should be a number. Okay, if discount is not a number, wait, so can I do 2 ifs? No. Why not? Okay, how about this? Since they both have to be ints or floats, I'll say if price or discount is not int or float. Yeah, the price should be a number. Oh wait, crap. No, that's not gonna work. Dang it. Okay. Well, I guess I can do an elif. Is that going to be a problem? Yeah, we'll give it a shot. Discount is not int or float. Then return the discount should be a number. Okay. All right. All right. Okay. Elif. Oh, geez. Somehow it just feels like I'm doing something wrong by putting a bunch of elifs. Like I'm gonna have to do something a little more complex than that. But we will, well, burn that bridge when we get to it. If price is less than or equal to 0, if elif price is, oh wait, no. How do we do this again? Less than or equal to 0. Return the price should be greater than 0. There we go. I mean, I guess this makes sense to have a bunch of elifs here because, oh boy, I don't know. We're just gonna keep trucking along. Elf discount is less than 0 or greater than 100. Okay, I think I can do then, I'll put a 0 on this side. 0. Maybe I'll put a 100 on this side. 100 is less than the discount. Oh boy, yeah, this isn't exactly, oh, this isn't great. Oh, okay, no, I'm not gonna do that. I'm gonna say if 0 is greater than the discount, or greater than 100. Wait, discount is less than 0 or greater than 100. Colon. Function for return the discount should be between 0, oh boy, and 100. Dang. Alright. Both inputs are valid. The function should calculate the discount as a percentage of the price. Function to return the final price. Oh man. Okay, so if the price of item is 50 and the discount is 20, then the discount amount is 10 and the final price. So the function, okay, so wait, I don't know if the whole thing needs to be an if statement. I think we can say, well, okay, actually, we can say else and do the whole rest of it in this else thing. So price this part I think should be the easy part. Yeah, this is what I get for not getting 8 hours of sleep. Oh boy. Okay, so price and then I'll have to return final price. Well, okay, so discount is percentage. So, man, so I'm gonna have to take the price and then multiply it by, man, how would I, oh boy, my math skills are not, I'm out of practice. It's been a while since school. Boy. How would I just can't think of the syntax of that. Like I get like 20% would be, you'd like divide it by 5, right? But like, so I'm multiplying it by the percentage. So I guess it would be price multiplied by percentage. So it would be discount divided by 100, right? So like, so if the discount is 20, then what would it be? 100 divided by 20? No, that'd be 5. No, the other way around. Yeah, okay. Discount divided by 100 would give me the percentage, I think. Slash 100. We'll put spaces to be Pythonic. Yeah, so the discount is 50. It'll be 50 divided by 100, which is 0.5. And multiply the price by 0.5. Okay, and then from that, I guess I'll store it as a variable. That'll make it easy for me. Oh, wait. Yeah, hold on. Okay. Yeah, we'll say it's better to do it over here. I think you could do it the other way around, but that's not very readable. Discount amount equals price times the discount divided by 100, which is what the percentage is. Okay, so discount amount, and then we'd say final final price equals price minus discount amount and then I guess we'd say return final price. Yeah, that works, right? Oh, okay, so let's say it says it should return it, but didn't say anything about printing, so this is just for my benefit here. Print apply. Oh, that's a function, apply, or something like that. It turned blue. Apply discount, and then in the thing we'll do price. We'll use the example they gave us, 50, 20. The price should be a number. I put 50. If price is not int or float, return the price should be a number. Okay, well, I messed something up here. Did I just spell something wrong, or did I actually just do this whole thing wrong? Why would it return the price should not be a number? Because price in this case is 50, which is an int or a float. Maybe it's these parentheses. Okay. Maybe there's just something I don't understand about this syntax. Like I'm not supposed to say int or float. Alright, well, back to the drawing board. I think this mostly makes sense. I actually think it's very much this, and probably this as well, that's going to end up being a problem. See, if it's returning this, that means it immediately stops here if price is not int or float. Yeah, I think I just like did something wrong here. Okay, we're gonna check out some of these functions and scope. I don't think that's it. Would it be booleans and conditionals? Let's look through here. Let's just try doing the double equals. Oh, that just does not make sense. Okay. Okay. We're not gonna try that. Didn't work. Okay, so this like doesn't break it, but it just doesn't do what I want it to do. If age is that. Alright, no. Okay. I need it to look for the data type. Yeah, this. Okay, nope. Okay, so this is probably where I'll learn about data type. Okay, wait, okay, we learned something about like well, oh boy. Earlier when there was something else about booleans somewhere else. I mean, there's no way this was the first time they brought up booleans. There was certainly something else. Was it data types? Understanding variable and data types. We're gonna try this. I don't know, man. Type. Maybe I should say if type price is. Okay. Wait, let's see. If type. Yeah. Alright, we'll try this. Alright. Oh, yeah, that looked like it worked. Yes, sir. Alright. Yeah, okay. That's all it took. We fixed it. We fixed the whole code. But just to be sure, let's say the price is like -1, less than 0. Wait, 0. The price should be greater than 0. -1. Oh, wait. Wait, so, sorry, we'll make it 50, and then we'll make this discount 0. Oh, wait. Okay. -1. Ooh. It's supposed to not work if the discount is... Ooh, okay. Alright, so I guess the way I typed in the discount thing actually doesn't work the way I thought it did. Alright, okay, so instead, I'm going to say if... We're just going to make it very ad hoc. Make it very, like, plain. So if discount is less than 0 or discount greater than 100, then it'll say, okay, now let's try this. So -1 should not work. Discount should be between, okay, and then 101 should not work. All right, okay. Yep, I think we've about fixed this. Gonna get rid of this print thing. Well, actually, let's just comment it out. Just kind of not necessary. Okay. Yeah, so function, apply discount. Should take price and discount. It should do that, it should do that. We've determined it does this. And then lower than or equal, it should say that worked. We made that happen. So, oh, I see. Actually, we'll uncomment that. We'll say if it's 120, then it should return 80. Yep. If it's 200, and this is 50, then it will return 100. Yep. Apply discount 50 and 0 will be 50. When apply discount is called with a discount of 100, then it should return 0. Oh. Yep, okay. When apply discount 74.5, and 20.0, uh-oh. Now it says the price should be a number. Well, see, in that case, the type of the price is float. Alright, okay. We're just gonna brute force this a little bit. Okay. So first... is not int or type. Well, maybe I should just say or not float. Okay. Or type price is not float. Oh, I see. Okay, I made quite a foolish little mistake. Actually, no, I didn't. Let's try this. Is not int. Has to be both. And type price is not float. Yes, okay. And now we're gonna do this again. So if type discount is not int and type discount is not float, 59.6. All right, we've done it. Run the tests. Yes. Marvelous. Okay. All right. Things are going great. We've done 2 labs now. We've done actual projects. I'm feeling, yeah. We're rocking and rolling now. We're really learning for finally. I hope this RBG character thing isn't too complex, but that's kind of like these last 2 bits. I mean, I can handle a quiz. That's way easier than actually having to build something. And review is, I mean, that's just self-explanatory. So this RPG character is the final boss of these 102 initial steps. And this, it's like 74 out of 102, but we're about to knock out like 25 of them. We're getting this done, and if I start feeling real sleepy, I'm just gonna call it. I really need to focus more on not messing my sleep up. Also, I don't know. I think I want to start focusing on increasing the quality of my videos and streams a little bit. Just little things like I've noticed I'm really quiet. Right now I'm trying to talk closer to the mic because like I don't exactly know how to fix that. My mic's gain is all the way up. And I did all this stuff with like compressors and noise suppressors. The noise suppressors made it so you can't hear my fan and computer now. But like I feel like it made the quality of my voice sound better, but now I'm like quiet, or I'm like really quiet compared to other videos. And I don't know, I feel like my S's still sound very strange. Like my mic has a pop filter sort of, but I'm not sure if it's really meant. It's more like a dust cover than anything. It kind of just prevents it from getting all dusty. I do have a filter, so maybe I should try that. And I'll give it a shot next time, but I don't know. Production value, I feel, can use some work. And also, I don't know, I don't have a description for my Twitch channel or YouTube channel or anything like that. I haven't set any of that up. I'm really just going all in on the coding right now. And that's fine. That's kind of all that matters to begin with. It's not like I'm trying to like become famous or anything. I'm just trying to, I don't know. It's providing me with lots of motivation, and it makes me feel like I've got like, I don't know, it makes me feel like I'm not alone in all this. Even though I kind of am right now. It's still good. It's like writing in a journal, kind of. But I'm like learning Python. Anyway, okay, Python, you declare a variable using equals the assignment operator and a value to assign on the right side. Create a variable called shift and assign the variable 5. If I remember correctly, let me look at this really quick. If I remember correctly, I had like done a bunch of these things and they were checked off, and then later they added a bunch of stuff because I had like later things checked off, but then there were things in the middle that weren't checked off. So I think they were added and they were new, but this Caesar cipher thing was definitely there already. So I think they like added some of these things in between. So I think basically since the Caesar cipher was already there, I think we're gonna be like repeating some lessons we've already done, because they like I think they revamped the course to better like work you up to like later stuff, but then they didn't change anything about this Caesar cipher workshop. So this might just be some review. It looks like we're starting with some basic stuff again. We're like starting over. Like this is easier than those other workshops. In previous lessons you learned about different data types you can store. You can assign an integer value. You need to assign a string with a sequence of characters. Declare another variable called alphabet. Yeah, this is a lot more simple than the stuff we've been doing. Assign the string. Oh boy. You just want me to type in every single letter? Okay, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Huh. You know, I've never, ever since I learned like touch typing, or like, I think that's what it's called, like typing without looking at the keyboard, I don't think I've ever just typed out the entire alphabet. That was actually way quicker and easier than if I like was finding, like using my eyes and finding every single letter. What? Declare another variable called alphabet and assign the string A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. What did I do? A, B, C, D. Did I spell alphabet wrong? I didn't. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Oh, it's a string. Oh, my lordy. Okay. Huh. It's always something like that. Something very simple. I would have noticed it quicker if I looked at the terminal a little sooner. Wait, is this called the console or is it the terminal? I don't know what this on the right side is. I've been calling it the terminal, but it might be the console. Okay, let's go. Here we go. Become an advertiser. I like this animation implies that like there's all these pop-ups showing up and you have to close them off, but it's just this one neat little animation. And this is a lot shorter than like a YouTube ad or something. Or like a Twitch ad. Yeah. In this workshop, we build a Caesar cipher. It's one of the simplest techniques to encrypt text, which consists of substituting each letter of plain text with the letter found at a fixed number of positions down the alphabet. With a shift of 5, A would be replaced by F, B by G, and so on. Okay. You'll need to create a new version of your alphabet that starts at the position indicated by the shift. As you learned in the previous lesson, you can extract part of a string using slicing. Okay, now this is newer stuff we haven't done yet. I mean, we've read about this, and I think we did a little bit of this on learnpython.org, but not here. So, we'll go shifted alphabet and use the slicing syntax to assign it the portion of alphabet that starts at the index of shift. Equals, then call the built-in print function to print shifted alphabet on the terminal and look at the result. I mean, if we're doing this at step 3, what are we going to do for the other, like, 25 steps? Oh, golly. So, it would be 5 to the right? So it would be, oh, well, I guess I should say alphabet. What am I doing? And then it'll be 5. Well, wouldn't it be 4? Because the first part's 0. So we would say 4 and then colon, nothing. And then print shifted alphabet. E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, Z, V, X. Okay, so that's not, I mean, so normally a Caesar cipher, that means it would say A, B, C, D at the beginning. Oh wait, it starts at the index of shift. What am I doing? Okay. So I assume we're going to have to add in some other stuff to make it so it shows the A, B, C, D, E part. As you can see from the output, the shifted alphabet starts at the letter F because shift has the value of 5. But now the first 5 letters of the alphabet, A, B, C, D, and E, are missing from the shift. Okay, I'm getting kind of sleepy. I might just call it after. Well, I think I can finish this Caesar cipher thing Shifted alphabet starts at the letter F because shift has the value 5, but now the last 5 letters of the alphabet are missing from the shifted alphabet. You'll need to add them at the end of the shifted alphabet. The plus operator is used to combine two or more strings in a process called concatenation, like this. Modify the existing assignment of shifted alphabet variable. Use the slicing syntax to extract the missing portion of alphabet and concatenate it to alphabet shift. As a reminder, sentence start stop returns the characters of sentence from the portion start included to stop. Excluded. Okay. Well, I hope this is as simple as I think it is. Oops. Should just be alphabet. It'll be nothing and then shift, right? A, B, C, D, E. Yeah. Okay. Looks right. Sweet. Okay, now we just have 20 more steps. Now that you've entire shifted alphabet, remove the shifted alphabet. Okay. Great. The stir make trans parentheses method makes two strings of equal length and returns a translation table that maps each character of the first string with the corresponding character of the second string. Each character in the translation table is stored as a Unicode ordinal, a number that uniquely identifies the character. Huh? I mean, I guess I've never seen this method before. Ooh. Okay. Two strings of equal length and returns a translation table that matches each character of the first string with the corresponding character of the second string. Each character in the translation table is stored as a Unicode ordinal, a number. Sorry, I muted my mic to sneeze, but my mic is very loud when you mute and unmute it. I've noticed it makes like it keeps like the loud pressing of the mute button in the recording. I think I can just sneeze away from the mic. I've never sneezed while recording one of these before. That's funny. Turns a translation table that maps each character of the first string with the corresponding character of the second string. Each character in the translation table is stored as a Unicode ordinal, a number that uniquely identifies the character. Huh. You'll learn more about the type of structure returned by stir-make-trans later on in the curriculum. For now, create a translation table that maps the characters in alphabet to the characters in shifted alphabet and assign it to a variable named translation table. Alright, I think I have figured this out. Translation table equals the characters in alphabet to the characters in shifted alphabet. Oh wait. Translation table equals dot make trans. So the first string to the second. So alphabet, shifted alphabet. There we are. Looks about good. I don't fully understand what that means at all, but you know, it will. They claim that I will be taught that later, so I'm just not going to worry too much about it. This is called text. Assign it a string. Hello world. This will be the message to encrypt. translate method takes as the argument the translation table generated by maketrans. It is called on a string and returns a copy of the original string where the characters have been replaced based on the translation table. Oh, okay. Alright, I think I'm kind of making sense of that. So we'd say sentence dot translate. It takes the argument. It takes as the argument the translation table. So ours is just called translation table. Should be simple enough. Okay, assign it to a variable named encrypted text. So start with encrypted text equals. We'll do the translate on. Well, okay, first we'll do text dot translate and then pass in translation table as the argument. And store it in encrypted text. Alright, that's exactly right. Now, print encrypted text, so right. I just realized that this whole, I mean, it might be on purpose, but I can't do that thing that the text editors normally do where I can hit tab to finish the whatchamacallit, to finish off whatever I'm typing. Okay. As you can see from the output, the message has been encrypted. Your next step will be to make your code reusable in case you want to encrypt different messages. For that, you'll need to create a function. As a reminder, here's how to create a function named spam that prints spam on the terminal. Def spam, print spam. Create a function named Caesar. Put all your existing code within the function body. Pay attention to keep the same indentation level for all of the lines within the function body. I don't know if there's a quicker way to do that, but I mean, I don't think they expect me to know. I think they want me to just brute force it. This is called Caesar. Def Caesar, and then I do that. Do I need to do parameters? I wonder. I don't think they expect me to. I think they just want me to indent everything basically now. Oops. Okay. Alright. That looks about right. Okay, we've defined Caesar. As you learned in a previous lesson, functions can have parameters, which are variables that can be referenced within the function. Okay, the message to encrypt and the shift are still hard-coded in your function. Give your function two parameters named text and shift and delete the declarations of both the text and shift variables from the Caesar function body. All right. Text, shift, delete the declarations. Okay, I completely underestimated this Caesar cipher thing. It is not just rehashing stuff. I mean, it sort of is, but this is far more complex. Oh, boy. I'm glad they updated this before I attempted it. This would have been a lot more difficult. And then, like, so text and shift, and then delete declarations of both text and shift variables from the function body. Okay, so text, yeah, that makes sense because it's hard-coded. We don't want it to just always be hello world. And then shift is one that we type in later. Okay. Okay, that should be about right. Yep. Alright, now test the Caesar function by calling it with the string freecodecamp and the number 3 as the argument. Assign the function call to a variable named encrypted text. Huh? Okay. Caesar. And then we do the string v code camp in camel case, which we have not done much of yet since we're doing Python. I don't think they really like camel case. Although you can use camel case for your variables, it's just Python's all about those underscores. And the number 3 is the arguments. Assign the function call to a variable named encrypted text. Does that mean I should just make a variable called encrypted text and make it equal? I mean, we already did that in the function, but I think that whole scope thing means that that just basically doesn't exist outside the function. That's interesting. So it does assign it, but it's still printing it. It prints and assigns. Okay. Now your code is reusable. However, the Caesar function prints a message on the terminal and gives you back none by default. To prove it, print encrypted text at the end of your code. I just type this. Why am I having so much trouble? Oh. Encrypted text. This proves it. Oh, print. Okay. I was like, how does that prove anything? So it'll just say none, I guess, after I type this in. Yeah, okay. Odd. Alright, in previous lessons, you learned the return statement is used to return a value from a function so you can use it elsewhere in your code. Remove the print encrypted text call from your function. And delete the declaration of the encrypted text variable. Wait, what? And return directly. Oh, okay. Delete the declaration of the variable, which is this part, and replace it with the return keyword, I'm guessing. And now when we print it, it actually does the correct thing. Cool. Only 10 more steps to go. You might have noticed that, although the message is encrypted, the uppercase characters have been left untouched. This happens because the translation table does not include uppercase letters. To fix it, you need to modify the strings to your stir make trans call using the upper method. Update your stir make trans call by concatenating to each argument the uppercase version of the argument itself. Huh? So would I say upper? Yeah, concatenating to each argument the uppercase version. We have to use the upper method. So would we just say alphabet dot upper with parentheses? Free fode famp. Oh boy. And shifted alphabet dot dot upper. That looks very wrong. Wait, so update and that by concatenating to each argument. Oh. I'm concatenating it to each argument? So there'll be alphabet plus alphabet upper? this seems wrong. Should I use more parentheses? Uh-oh. Alright, well, hope this works. So I'll put one more parentheses. Shifted alphabet plus, and then one more parenthesis. Oh my gosh. That worked. Good grief. Okay, check your code. That's what they wanted me to do. That is complex. It's we're so many, we're like 3 parentheses deep. Wait. Yeah, make trans alphabet plus alphabet dot upper, shifted alphabet plus shifted alphabet dot upper. Wait. When I didn't put parentheses. Oh, okay. So I didn't need the extra parentheses. That just. The only reason it wasn't working is because I hadn't typed it in on both sides yet. Okay. So I just added a random extra set of parentheses for good measure. Not bad. Not exactly good, but it all worked out in the end. Now that you've implemented the basic functionalities of the cipher, it's time to add some validation. Well, we all need validation, don't we? For that, you'll need an if statement. Here's a reminder of the syntax for an if statement. If condition. Okay. At the beginning of your function body, create an if statement. Oh yeah, it would be here. Okay. For now, use true as the condition, and within the if statement, body, return the string, shift must be an integer value. Oh wait. When within the if statement body, return the string, shift. Okay. So, if true, that's just the condition. If true, return. Oh, a string. I put parentheses. It doesn't have to be. Okay. Shift must be an integer value. So that's a placeholder, I assume. Your string to return shift must be an integer value from your if statement. Did I spell it wrong or something? Oh, it needs a period. Okay. Usually, almost every single time in these other workshops and stuff, and in the labs too, when it wants me to return a specific thing, it doesn't require a period. That's the first time they've done that. Yeah, and that was the deciding factor, because I didn't put a period. It didn't do it right. But you know, that's just how coding is. Things have to be very precise. This website is not unlike how all coding works. The isInstance function returns true if the first argument is an instance of the second argument and false otherwise. It returns true if its first argument is an instance of the second argument and false otherwise. Okay, isInstance hello world string is true, isInstance 42 int. Replace the current if condition of your if statement with an isInstance call. Pass in shift as the first argument and int as the second. Okay, that makes sense. Is instance shift if that shift is an integer. That seems incorrect. Because that would be, if its shift is an integer, it would return. Okay, maybe we're gonna fix that later. I think that might be intentional. Yeah, it's intentional, because that doesn't make sense if you, because it's a 3 in this case, which means it is an integer. So, but we made it so if it is an integer value, it tells you it should be an integer value, even though it already is. As you recall from the previous sessions, the not operator. Okay, yep. I'm always speaking too soon. The not operator is a unary logical operator that negates an expression. Use the not operator to fix the condition of the if statement so that your function returns shift must be an integer value when shift is not an integer. If not is instance shift int. A negative or null shift should not be accepted by your function. Therefore, after your first if statement, create another if statement that checks if shift is less than 1 and returns the string shift must be a positive integer. If shift sometimes, oh geez. If shift is less than 1, return, no, not that, shift must be a positive integer. Cool. Your second if statement should return shift must be a positive integer. Oh my gosh, it's the period again. There we are. Step 20. As you've already verified, the shift passed to encrypt the text should be positive. It cannot exceed 25, though. Oh yes, it starts from 0. 25 would be the z. Add a second condition to the if statement that verifies that shift is greater than 25. Add a second condition to the if statement that verifies that shift is greater than 25. Remember that the logical OR operator in Python is implemented through the OR operator. Or the logical OR operation in Python is implemented through the OR operator. Also update the return message as shift must be an integer between 1 and 25. With a period at the end. Must be an integer between 1 and 25. Alright, so add a second condition to the if statement. Or shift is greater than 25. Seems about right. 21. Python allows you to specify a default value for the parameters in a function. Creating a function that can be called with fewer or no arguments. Here's how to create a function with a name parameter that has a default value. Wait. So if you define greet name equals Polly. Return hello plus name. Greet. So, okay, so this example function would always greet Polly. Every single time you call greet, it's just always going to say Polly. That's what they mean. So we're creating something where encrypt equals true. In this example, they're not putting spaces with the equals and stuff. Oh, wait. Add a third parameter named encrypt into your function and give it a default value of true. I did. Python allows you to specify a default value for parameters in a function. Create a function that we call viewer no arguments. With the parameter name that has a default value. Oh, whoops. I guess the T needs to be capital. Okay, yeah, I need to think about that case sensitivity. Okay. You are going to use the parameter added in the previous step to determine if the function should encrypt the text passed to it. Default behavior encrypt equals true, or if it should encrypt an encrypted message, or decrypt an encrypted message. Okay. Create an if statement that checks if encrypt is not truthy. Okay, so I think they had us put true there as another placeholder, and then later they're gonna have us switch it again. Oh. Alright, we gotta finish this up. It's time for me to sleep. What time is it? 1:54. Yeah, we're making great time and making great progress. Everything's going fantastically. Tomorrow I can focus all my attention on that RPG character lab. Create an if statement that checks if is encrypt. So let's say if bool encrypt is true, and then we'll set shift equals negative shift. Is that how it works? This is necessary to enable the shift to take place in the opposite direction with respect to the encryption process. You should set shift to negative shift when encrypt is not truthy. Oh. Should I just say not true? I mean, I guess. Same thing as saying false. It'll probably switch it to whatever it's supposed to be. We'll see after a word from our sponsors. Acquire skills faster. Help millions of people learn. Help bears learn to fly. Fantastic. Okay. Ask me later. Please feel free to ask me later. Declare two functions if not encrypt. Oh. Okay, that's a lot simpler than what I wrote. What I did like if bool encrypt is not true. You can just say if not encrypt. I'll try to remember that. And this stuff, that's difficult to read. I bet you in another text editor it would be all sorts of different colors, so it would make it slightly easier. Okay, declare two functions named encrypt and decrypt with both text and shift parameters. Declare two functions? So I'm gonna, oh, okay, so oh, and we'll return this function in these functions. Okay, that's cool. That's pretty cool. Okay, declare two functions. Encrypt. Man, I'm always worried I'm gonna misspell encrypt because it's such a strange looking word. It just always looks like it's spelled wrong. Text shift. Def decrypt text shift, and then return a Caesar call passing in text and shift from both your new functions. but make sure to pass in also false as the third argument for the decrypt function. All right. I'll try. Okay, so return Caesar. Oops. I just realized why I didn't do indents on its own. Because I didn't do this. And then this calls Caesar. This just does text and shift. And I should have probably done return Caesar text shift. Now this one will be return Caesar. This one's text shift and false. Okay, that can't go wrong. Yeah, okay. Oh, they spaced it out a bit more than I did. Oh, and instead of just typing in false, they did encrypt equals false. That's strange that they let me get away with just putting false in as the third thing. That's kind of exactly what they told me to do. But now they've like corrected it like this. I wonder if that's important. Time to test the encrypt function. Using the same arguments, replace your Caesar call with a call to encrypt. You'll see the same output. Okay. Alright. And then finally, now you're going to test the decrypt function. Replace the value assigned to encrypted text with the following string, which represents a message to decrypt. Okay. Well, that's fun. That's pretty fun that they're actually making it, because this is the last step, I think. Okay. P, B, capital P, B, H, E, N, T, R, B, F, S, B, H, A, Q, V, A, H, A, Y, V, X, R, Y, L. C, Y, N, P, R, F. Then declare a variable named decrypted text and assign it to decrypt. Oh boy, okay. What? I think I did something wrong. Now you're going to test the decrypt function. Replace the value assigned to encrypted text with the following string. Oh, I see. So I'm just supposed to switch out this whole encrypt function with literally just that string. And then declare a variable named decrypted text. And assign it a call to decrypt. With encrypted text. And a shift of 13. And finally, print decrypted text in the terminal. courage is found in unlikely places. That's not what I expected. That's pretty cool. You should assign to encrypted text. Oh, great. I have to put a period. That's always gonna... I need to pay more attention to that whole thing. Marvelous. I can post this on x.com or on Instagram or Blue Sky. Not gonna do that. Alright. Cool. Okay, now it's about time I get off to bed. I'm already all cozy in my PJs, and we're at 99 out of 102 steps. We made great progress. It's just these last 3 things. And we're done with this section. Python basics. Oh boy. And then we're doing loops and sequences. Oh, then dictionaries and sense. Oh me, oh my. Okay. Oh. That's fine. We're rocking and rolling. Things are going fantastically. Okay. Alright, I think later on I'm gonna find the website I use to teach myself to type without to like type properly, and then I'm gonna maybe I'll try and work that into a stream or a video one of these days. I'll start getting better at typing. I think I'm not doing such a I don't think I'm doing such a bad job so far, but you know, I'm gonna want to get better at that. It'll just make things faster in the long run. Plus it'll be another fun thing to do. Yeah, so thanks for watching. I'm going to bed now. Arrivederci. Sayonara. Bye bye.